All right, a third log scale, and again another one that some of you will be very familiar with from chemistry class, is the pH, a pH scale. pH is a logarithmic scale where the pH rating, so you, for instance, in example 3, we have water has a pH level of 7. Where does that 7 come from? Well, it's a log scale. Um, this H plus is the concentration of positive hydrogen ions. All right, and if you're not taking chemistry, then this might not mean much to you, but it doesn't matter. This is just a log scale, and so if we remember that this H plus thing here is the concentration of hydrogen ions, even though we might not know what an ion is, or hydrogen or pH, it's still a log scale that we can do a calculation for. What's different about this one is there's a minus, and so this idea, this concentration of um, hydrogen ions, it ends up being a small number. It's like usually 10 to the exponent negative something, and so negative whatever. And when I take the log of that, it ends up a negative number. And so they didn't want the pH scale to be negative because that's confusing. And so they put a minus in front of it to wipe out the minus sign that would be come from taking the log of it. So a little bit of a different scale than the other ones, but let's get at it. Water has a pH level of 7. What is the hydrogen ion concentration? So again, I'm just going to use the formula, just straight copy it out. And I don't know if this is the same symbol that Miss Hillary or Miss Ruston use, or whoever's teaching you chemistry these days, but that's what and that's what we want to find, right? So it says the pH level is 7. Then here's the little formula of where it comes from, and I want to solve for that. Notice, got to divide by -1. And if I want to figure out the hydrogen ion concentration, then I want to get rid of log base 10, so that's exponential function base 10, and that in fact gives me my answer, 10 to the exponent. That's, and you see, I told you it's a small number, 0.000007 is the concentration, and the units, as any good grade 12 chemistry teacher or chemistry student will tell you, is that it's in moles per liter. And everyone knows what a liter is. Not everyone knows what a mole is, but these are the units, and that's not real important. Okay, easy calculation there. What's kind of a more fun one is this one. And so it's, you want to dilute hydrochloric acid to a pH of 3.1. By what factor must you dilute the solution? So this is similar to the decibel one and the Richter one, and we could think of, how much more concentrated is hydrochloric acid than after you dilute it, right? How much more intense is one solution than another solution? And actually, we could just do the same calculation that we did for Richter, which is just subtract them and put them into an exponent 10. That works. But I'm going to actually go through the procedure and sort of show you why that calculation, subtracting them and putting them into an exponent 10, works. So I'm going to do, find the pH, and this is of, let's first do hydrochloric acid. So this is the concentration for hydrochloric acid, and I'm going to calculate what that is. The pH was 1.7. H for hydrochloric, and then I'm going to solve for that, make it negative, exponential function base 10. So the concentration of hydrochloric acid is that many moles per liter. Okay, and then if I want the weaker one, this is actually weaker, we'll see. concentration of the weaker solution is 3.1. You're saying, oh, hang on, Restall. The pH is higher though. Well, we'll see why that makes sense in a second. Divide by -1. Same calculation now, 3 times we've done. The weaker one, exponent 10 on both sides. So now, which of these numbers is bigger? This is supposed to be 1.7 here, right? Well, this is like 0 and then some, 1, right? Because I'm just moving the decimal place to the left almost 2 spots. This has got 3 decimals before I get any digits, right? So this one is a lot bigger. This one is a lot more concentrated. And so if I want to find out how many times stronger it is, then the number of times stronger would just be this one divided by the weaker one, right? How many times that's divide? How many times is divide? And then what do? With 2 powers at the same base, I subtract the exponents. Subtract the exponents, watch your integers there, and that's 10 to the exponent 1.4, which is 25.1 about. And notice there's that expression that I would have got if I just took the 2 pHs, subtracted them, and put them into the exponent 10. I could have got the right solution. And is it okay if I do that? Yes. But I wanted to show you why that worked here, okay, after we got used to them. So what's the conclusion? Therefore, we'd have to dilute the acid by a factor of 25 times about. How do you actually do that? I don't know. That's a chemistry problem, and I'll let you talk to that about that with your chemistry teacher. All right. So again, that's why the calculation would work. This is the calculation that I'm expecting. In fact, right here is enough. You subtract the 2, 3.1, subtract 1.7 is 1.4. That goes into the exponent. You do that calculation, and that works just fine. And that's the same thing as the decibels, the Richter scale, and the pH. Do I have to memorize all those formulas? You are responsible for the formulas, yes. But did we actually really need to use them? Not much. Where's the homework? 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 There's the homework. A bunch of little bits and pieces and an FAQ. Ending off the video, this is an old video, but it really is, I think it's a neat way to think about how big and small things are and why these log scales are necessary. So this is an old video, but really worth watching. So I hope you give that a spin and enjoy that. And that's it.